Okay, good morning everybody. As you may have heard, we are moved to remote studies for today due to the winter weather conditions. Looking out my window right now, there is a lot of snow and ice, so I am glad they made this call. Okay, we are going to continue our discussion of solving quadratic equations. Last time we learned a couple different methods. We said we can do this maybe algebraically. We can do some manipulations to our equation and solve for x. We can also do this graphically, right? We can plug our equations into the graphing calculator, and then depending on if there's a 0 on one side of our equation, we can find the x-intercept of that graph to solve it. Or if there are things on both sides of our equations, then we can find where those two lines intersect in the plane. Okay, we are going to continue that and talk about a few other methods that we can use to solve quadratic equations. So we want to talk about this idea called the square root method, which is a special algebraic method. We also want to talk about solving quadratic equations with the quadratic formula. If you're lucky enough to have heard the song before by someone else, then that's great, but we will just talk about the formula. And we also want to talk about quadratic equations that have complex solutions, right? So in this class, we've really only talked about real numbers, but there are numbers outside of that realm, and sometimes when we solve these quadratic equations, we are no longer in the real numbers. So sometimes these quadratic equations have solutions that are actually complex numbers, which means that they have some multiple of the imaginary unit I, which is the square root of -1. And we'll talk about that a little bit later as well. So before we get into it, I first want to bring up this graphic of a bunch of perfect square roots. So we've said before that a perfect square number is a number that we can write as some number raised to the 2 power, right? So like 1 squared is 1, and in turn the square root of 1 is also 1. Okay, for another example, we've got square root of 4 equals 2 on this list. Well, we know that 2 squared gives us 4, right? So 4 is a perfect square. And we're saying that, well, 2 is the square root of 4, right? Which means that 2 has to be a perfect square root. And so here is the list of the first 14 perfect square roots. And we will kind of try to work with these a little bit later. So keep these on the back burner of your mind. Okay, so here's this square root method. We're going to say that solutions of the quadratic equation of this special form, x squared equals c, right? So that's x squared just by itself, and that's equal to c, some constant real number. Well, we're saying the solutions of this equation are x has to be equal to plus or minus the square root of that c. Okay, so it's important to note that when we're taking the square root of both sides, we have to use the plus or minus symbol because there's both a positive and a negative value that when we square it, we get c. Right, so think of it like this. 2 times 2 gives us 4, but -2 times -2 also gives us 4. So if we want to take the square root of 4, we actually have to also consider that there is not just the positive 2 that gave us the 4, but also the -2 that gave us the 4. So that following this square root method, if we had x squared equals 4, then the solutions would be x equals plus or minus square root of 4. So x would be plus or minus the square root of 4, and that would be plus or minus 2. Okay, this would be the point where I would ask the class if they have any questions, right? But since we're online today, it's not really going to work like that. So if you're right here and you have a question, go ahead and shoot me an email and we can talk about it. Okay, so now we've got some quadratic equations and we are asked to solve them using the square root method. So this first one over here is x squared minus 25, and the other equation is x squared equals 20. So to solve this first one, what we're going to have to do first is we got to get it into our form to use the square root method. And we said the square root method form looks like x squared equals c. So if I move this 25 to the other side, then I'll have x squared equals 25. And then for my square root method, I know that x has to be plus or minus the square root of 25. Well, if we recall our back burner of the mind and we say, well, 25 is actually a perfect square root, then we know that x has to be plus or minus 5. Okay, as for x squared equals 20, we're going to first note that 20 is not a perfect square root. But what we can do is we can still take the square root of both sides, right? And then we'll have x equals plus or minus square root of 20. Well, 20 is actually 4 times 5, and the square root of 4 times 5 happens to be the same thing as the square root of 4 times the square root of 5. So what we're going to have in this case is x will be plus or minus the square root of 4 times the square root of 5. We know the square root of 4 is a perfect square, or excuse me, is a perfect square root. So we'll get x is equal to plus or minus 2 times the square root of 5, right? We just evaluate that perfect square root. Okay, yeah, so in the slides here, we're saying x is plus or minus square root 20, but we got to figure out how can we simplify that square root of 20. I just gave us the basics of it, but here's that in more detail. So if we have something under the square root, and that something is 2 pieces multiplied together, right? So the square root of a times b, we're saying that we get to break up the inside of the square root into factors that are either perfect square roots or prime numbers. Right? So that means that square root of a times b actually turns out to be the square root of a times the square root of b. So the root of a product is the same as the product of the roots. Okay, that being said, we can take anything that looks like, you know, the following square roots, and we can simplify them. Right? So square root 20, square root 48, square root 162. Okay, and we can do that by just breaking up that number under the hood, under the square root sign, the radical. We break that up into some factors. So we want to break the number 20 into some factors, where one of them is going to be a perfect square, and the other one may be prime, or it may be a product of primes. So if we've got square root 20, we know that square root 20 is the same thing as square root of 4 times 5, because 20 is 4 times 5. And so then we know then from this rule that we can break up that radical, right? So then the square root of 20 actually becomes the square root of 4 times the square root of 5. Well, we know square root 4 is perfect square root, so it simplifies to 2. And so then 20 becomes 2 square root 5. Same deal with 48. We can break 48 into 16 and 3. 16 is a perfect square root. 3 is not. So we evaluate it and we get 4 square roots of 3. Okay, this one's a little bit bigger. Square root of 162 is actually 81 times 2. Right, so we can break that part up under the hood, and then we'll get square root 81 times square root 2. Evaluating this gives us 9 square roots of 2. Okay, so just to recap this slide, if we have the square root of a product, it is the same thing as the product of square roots, right? So if a times b is under the square root, then that's the same thing as saying the square root of a times the square root of b. Okay, Now we want to use this, right? We want to use this idea to help us solve equations. So if we take a look at A says 2x squared minus 16 is equal to 0. And so we want to be able to use our, oops, I hit a wrong button there. I accidentally jumped forward a bunch. Okay, so we want to be able to solve these equations using our square root method. So we note that A is not in its required form yet. So let me first move that 16 to the other side. And I'll have 2x squared equals 16. Well, this still isn't really in the form, so we got to divide both sides by 2. And then I'll have x squared is equal to 8. Well, from my square root method, I know that x has to be plus or minus the square root of 8. Okay, is 8 a perfect square root? No, it isn't. So we need to take a look at its factors and see if we can break up the square root of 8 at all. Well, I know that 8 is equal to 4 times 2, and I know that 4 is a perfect square root. So that gives me x equals plus or minus the square root of 4 times the square root of 2. When I simplify this, I'll get x is plus or minus 2 square roots of 2. Okay, again, if you have any questions about the content that we're going through, you can't really ask them right away, but go ahead and shoot me an email as you're watching this video. Right? I should be able to answer some questions through email this week. Okay, looking at part B, we've got x minus 6 squared equals 18. So, first thing we have to ask ourselves is this thing in the form that we require it to be in to use this square root method? Well, to use my square root method, I need to have something raised to the 2 power, and I need it to equal some constant real number. And so right now I have this quantity x minus 6 is raised to the 2 power, so that's good. And on the right side I have equals 18. So I've got something squared equals a constant number, which means I can take the square root of both sides right now. Right, and if I do that, I'll get x minus 6 on the left will be equal to plus or minus the square root of 18. Okay, well, can we break up this square root of 18 at all? We know that 18 is not a perfect square root, but we also know that 18 is equal to 9 times 2. Okay, well, using our rules about square roots, we can break this up into the square root of 9 times the square root of 2, or rather 3 square roots of 2. Okay, so that means my equation now reads x minus 6 equals plus or minus 3 square roots of 2. Well, notice if I want to get a solution of this, I need to have x equals. Right? And right now I've got x minus 6 equals. So let me move that 6 to the other side, and then I'll have x is equal to 6 plus or minus 3 square roots of 2. Okay, I'll leave those answers up for another brief second so you can check your own work. But we did talk through both of these here. Okay, again, if you have a question, go ahead and send me an email right now. Because if it doesn't make sense now, then you're going to have a hard time making sense of it later. Okay, we now want to talk about a new formula for solving quadratic equations just in general. Right, so if we have some quadratic equation, ax squared plus bx plus c is equal to 0, we know that a is not 0, then we're going to say that the solutions of that quadratic are given by this formula here. X equals negative b plus or minus the square root of b squared minus 4ac, and then that whole thing is divided by 2a. So we are saying that we can use this formula to solve any quadratic equation. Okay, let's go ahead and try to use this now to help us solve a quadratic equation. So we've got this given quadratic is 6 minus 3x squared plus 4x equals 0. So we know it's quadratic because we see the highest exponent is a 2 on that x, but we also notice that it's not really in our standard form. Right, we say that we have ax squared plus bx plus c. Well, this equation isn't in that order. So I can reassociate, and I'm going to move the 6 to the opposite side of the 4x, but still on the same side of the equal sign. Right, so then it'll read negative 3x squared plus 4x plus 6. So all I did was shift the order of this left-hand side. And that's all going to be equal to 0. Okay, well, to use my quadratic formula, I need to know what my a, b, and c values are. So I can look at the coefficients of my equation. A is attached to the x squared. That's a negative 3. B is attached to the x. That's a 4. C is by itself. That's a 6. Okay, so we've got A, B, and C, and now we can start using this quadratic formula. Right? So the quadratic formula says x is equal to the negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So now I'll start plugging stuff in. So b is 4, so now I'll have negative 4 plus or minus the square root of 4 squared minus 4 times a times c. Well, a is negative 3 and c is 6. So a times c is negative 18. So then I'll have negative 4 times negative 18 there under the square root. Okay, and we're saying all of this is divided by 2 times a. Well, a is negative 3, so 2 times a is negative 6. Okay, so we've plugged into our formula. Now we just need to simplify. So let's work on that square root first. Under our square root, we've got 4 squared minus 4 times negative 18. Well, I know I've got minus 4 times minus 18, so that's going to be a positive. It's going to be the same as positive 4 times positive 18. So if you got a calculator or quick with mental math, go ahead and do that real quick. And it should be 72 is 4 times 18. So now under the square root, we've got 16 plus 72. That should be an 88. Okay, so let's rewrite this back in our formula. We'll have negative 4 plus or minus the square root of 88, all divided by negative 6. Well, can we break up that square root of 88? I know that 88 is 8 times 11. And I know that 8 is 4 times 2. So I can break this all up, and I'll have the square root of 4 times the square root of 2 times the square root of 11 is the same as the square root of 88. Okay, so simplifying my square roots, this gives me 2 square roots of 22 is equal to the square root of 88. Okay, substituting that back into our formula, we now have negative 4 plus or minus 2 square roots of 22 divided by negative 6, and that should be our x value. Okay. We got to keep trying to simplify this out because we can. So I see a 2 in every term. Right? So I'm going to divide everything by 2. And then I see a negative in the top and bottom, so I'm gonna play with that as well. Okay, so if I first divide everything by -1, then I'll have 4 minus or plus 2 square roots of 22 all over 6. Okay, further, if I divide everything by 2, then I'll have 2 minus or plus the square root of 22 divided by 3. Okay, and I can break this fraction up since I've got stuff added or subtracted in the top and I've just got one number in the bottom. Then I can say that this is the same thing as 2/3 plus or minus the square root of 22 over 3. So I know that one was kind of complex, but if you bared with me, then we can find out this is about 2.23 and about -0.897. So these would be the two solutions here to this quadratic equation that we found using the quadratic formula. Okay, let's try to start applying this. So if we've got data from the years 2020 projected to 2025, the number of millions of 5G smartphone subscribers worldwide for the year can be modeled by this function here. S of t is 54.5 times t squared minus 250t plus 1. Okay, we're saying that t is the number of years after 2020, and then we're saying that S of t is the number of millions of 5G smartphone subscribers. So S, number of millions subscribers. Okay, what are we asked to do? We want to find the year after 2020 that the number of 5G subscriptions worldwide is equal to 2.951 billion. Okay. Well, first thing we should note, what is the output of our function? Our function outputs a number that represents the number of millions of smartphone subscribers. So if we want to find when this number reaches 1 billion, we've got to kind of change the billion into terms of millions. So I can do that by just moving the decimal place 3 units towards the right, and then I'll know that 2.951 billion is actually 2,951 million. Okay, so now that I've got that number in millions, I can set it equal to my function. So 2,951, I'm going to set that equal to my function, so equals 54.5t squared minus 250t plus 1. Okay, so from this point, this would be the situation where I would normally ask in class, what do you think we should do? We just learned this new quadratic formula, right, where we can solve these algebraically, but that's kind of tedious, right? And last time we learned about graphing these things on our calculators. And so if I wanted to graph this equation, then it would look something like this. I can take 951 equals, I want to first graph this as 2 separate lines in my calculator. So first I'll say y equals 2951, and then I'll say y equals 54.5 t squared minus 250t plus 1. Okay, now that I've got both of these sides of my equation graphed, I've got to look for something. And so I want you to ponder, am I looking for the x-intercept or am I looking for the intersection? Okay. So if you said we are looking for the intersection, then you would be absolutely correct. So what I need to do now is I need to find where these two things intersect. So I'm going to have to zoom out so I can see this line y equals 2951, and I want to see where does that intersect my new graph of the given equation. And so if I'm looking at this range here, I can see my horizontal line, y equals 2951, and I can see that blue parabola. It looks kind of like two vertical lines here, but we do know it's a quadratic equation, right? We just plotted it. We just kind of can't really see a complete graph at this scale. Okay, but we do want to find where this green line intersects this blue line. And if we use GeoGebra, we can see it happens around -7, and it also happens around +7. Okay, so I'll say -7.4 and +7.4. Okay. So now we know that x equals -7.4 and x equals +7.4 are both solutions to this equation. Right, but we've got to kind of figure out